Welcome to Brain Vision.
The first thing to do whenever we're answering these types of questions is to define our H0, which is the null hypothesis and its corresponding alternative. So usually with most statistic questions, it won't matter the variables that we are dealing with. It could be the number of machines, it could be the standard means. So usually the null hypothesis, it usually states that the variables that we are dealing with are equal. That is, there is no significant difference between the variables that we'll be looking at. So what this means is the alternative is going to be saying there is a significant difference between the variables that we are going to be testing. So to determine whether or not we accept the null hypothesis, what we need to do is to look at our test statistic. So we determine our test statistic and we compare it against the corresponding critical value. So the difference between the actual test statistic and the critical value boundary is what then is going to help us determine whether or not we accept the null hypothesis. Now, looking at the information that we've been given, what we can do right here is to perform an F statistic test based on an ANOVA type of analysis. And looking at the information that we have, we're looking at an F value that is equal to 0.15. Now, the corresponding p-value based on this F value, it is 0.92769. So, based on this value, regardless of the significance level, it can be 0.05, it can also be 0.1, which is, these are the common significance levels. So for any value of alpha, we can tell that we have a p-value that is greater than that corresponding value of alpha. So what this means is we reject the null hypothesis and conclude the alternative. That is, we reject the null hypothesis and conclude to say there is evidence that the variables that we are dealing with are different. That is, there is a significant difference in the variables that we are dealing with.